Hi everyone, welcome to the next edition of Reline Live. I am joined by Don LeBlanc again, and we are going to be talking about large diameter reline projects. We previously were supposed to be discussing spiralite, but that's going to be rescheduled as our presenter came down with a flu. So we're going to push him for a week or two. And Don graciously jumped in and helped put this together for me yesterday so that we could talk to you guys about stuff. A little housekeeping. I am going to be monitoring the questions box. So if you guys have questions for Don while he's going through some of these projects that he's worked on, go ahead and shoot those in the question box and or into the chat box. I've got both of those up on my screen, and we're happy to take your questions for the next 30 minutes. Welcome, Don.
Thank you very much. Good to see you again.
Yeah, it's going to be a regular thing with us.
I know, right? That's okay.
Yeah. Okay, so I am going to share this presentation. I'm going to make sure I'm sharing the right screen. Nope, wrong screen. Let's see. Bear with me, guys, while you're seeing the play screen instead of this one. I don't know why. Let's see. Because I've got two screens here and it's not liking this. Let me try this one more time, Don, see if I can make it work. Let me see, and if well, I guess this is how we're going to see it. For some reason, I can't get it to move over to my other screen.
Okay.
Okay. Oops. Can you see this on your screen? Do you see it?
We do, yep.
Okay, good. There. Maybe? Yes, that's better.
Yep, that did it.
Now I got you. Okay. So tell us a little bit about this project.
Sure. So, I mean, I guess in general, this Reline Live with Cassie, she asked me to just highlight some options for larger diameters. And what we mean by that simply is usually typically greater than 60-inch 5-foot span. And I've been fortunate enough to have a number of large diameter projects come across the Northeast region here, which I've been involved with. And what you're seeing, I guess to kick things off, what you're seeing here is the probably the longest total footage of pipe that I've been, I think, involved with in any project to date. This total job was about 1,600 feet. What you're seeing there, yeah, it was a good project. It was a paved invert hose pipe, 120-inch, roughly speaking, hose pipes, double barrel, underneath Interstate 86. And they had quite a bit of cover. As you can see, the shallow cover you see in the picture on the right is actually just an access road behind the highway, and there was 55 feet of cover on top. So Cassie, you know, one of the things I often hear from some DOTs is they're not familiar with the fact that high density polyethylene liners can be buried as deep as 50 to 60 feet, even deeper sometimes. Do you see that out your way?
We don't see a lot of pipe buried that deep. I will say there's a couple, and I don't know if Kelly is on or not. He's done a couple of projects in Utah that have deep cover for sure.
Sure. We have, as you can imagine, quite a bit of terrain change out here in the Northeast. But out here in New York, this is actually an interesting territory. There's not a lot going on out there. It's they call the southern tier, basically, of New York. Beautiful country. There's a cult following cheese store in that town of Cuba, New York. But this one was 1,600 feet of 96-inch ID. So when we talk about profile wall high density polyethylene, that is usually an inside diameter dimension, and then the OD is in addition to that diameter. So this was 96-inch inside diameter, excuse me, and this was all welded together pipe. And one of the reasons the DOT chose this pipe is for service life. longevity, and obviously with the stream being what it was, there was some decent scour potential, hence the reason they had the paved invert in the hose pipe. So they like the abrasion resistant properties of the high density polyethylene.
Okay.
Really neat job. I had a friendly contractor do a fantastic job on that installation.
So one question that came in prior to the call was, when looking at jobs, because you started talking about why they chose it, the abrasion factors and things like that, what would you say are the top 3 factors that you take into consideration before recommending a product? Because you do a lot of recommending when you go out on these job sites, right? You're coming out, you're inspecting the pipe, you're going through it, and then you're coming in and saying, here's a few options that I would recommend, right? Just like we are. Okay.
100%, Cassie. Yeah, that's correct. And you know, I do have a top 3, which I'll give you a sec. I actually do a presentation called 7 Design Considerations for a Reline. And the 3 I think kind of hit the top are not in any particular order, but hydraulic considerations, constructive considerations, and then service life. And oftentimes service life, I mean, most of the things that you and I typically look at are like, hey, we want to push 75 to 100 years plus worth of service life underneath our highways and roads. So usually that service life thing is with automatic checkbox, because we know that everything that we're out talking about is going to offer a 75 to 100 year minimum service life. And then obviously, so the 2 that are left are hydraulic consideration and structural. So those are really the 2 top. And I would say that, you know, usually getting out in the field and doing the best site inspection that can be given for these larger diameter structures, usually you can walk through them. And, you know, doing the old tape measure thing is good. But if you can get a scan or a survey or even 3D LiDAR type material or feedback from your engineer or owner, that's the best in my opinion. That's the really good stuff. This slide that you have on here right here is a prime example. This was actually turned up as an emergency job. They had, once again, beautiful. A lot of people think of New York as only being the city, but upstate New York is a lot of beautiful country, as I've learned over the years. And this was actually underneath Route 4 up past like Lake George and all that. And the southbound lane actually failed. It collapsed. So they went in, they had to shut down the road. They were able to open up one lane back again, but in the interim, they had this structure underneath that they had to fix. It was somewhat of an ellipse shape, like a vertical ellipse. And so we put in a large diameter. Once again, you can see, so I show these 2 pictures so you can see kind of the condition on the left-hand side picture of what was found down in and dewatered this thing. And then you can see the grout tubes. If you guys watched Cassie and I's previous reline talking about grout, you can see some of the grout tubes hanging in the ceiling there. And they were able to actually pre-hang some of their blocking to prevent any flotation from happening during the grouting process. So this is before the liner is inserted, these 2 photos.
Is this the same?
Yeah, so gotta love the benefits of the old iPhone, the panoramic view on the top picture there.
Right, that's a great picture.
Yeah, the gentleman on the far right side actually brought his colleagues out, a lot of interns and some other young engineers that were curious to see the project. So they all came up from Albany to witness this job going together. And this particular contractor was obviously on a emergency on-call type of deal. So working with the state and working with the contractor to get this whole thing to come together was quite a unique and challenging task, which I think everyone did a really fantastic job of meeting the demands. Ironically enough, what you see there in the bottom right is a concentric reducer that is what's 14 feet in inches. So it's a 14-foot ID reducer. So it actually helped with the inflow on the upstream end of that pipe. Quite unique.
Yeah, that is I've never seen a reducer that big.
It was pretty cool.
Yeah.
So Kathy, I mean, do you see, I know for a fact you guys see a lot of these really, really bad pipes. And you get phone calls from folks who are like, oh, this pipe's too far gone. You ever hear that sentence?
Oh yeah, we get that a lot, especially where there's a lot of water. So, we do a lot in Oregon and Washington,
Sure.
obviously Idaho since we're based here, but with a lot of the fast moving creeks and streams and rivers, we can get a lot of rust, and what this looks very familiar on the top left.
The abrasion.
Yeah.
Absolutely.
Mhm.
Absolutely. And that's, I get that sentence all the time, either from an engineer or owner who might think that a hose pipe is too far gone to be a lining candidate or a slip line or a rehab candidate. And oftentimes, there is a possibility that you can salvage that culvert with a rehab. In this particular instance, this pipe was in horrible condition. It actually partially collapsed on the upstream 30 feet, but we were able to salvage it and bring it back to life. We used a 2-flange tunnel liner plate. We had to cut out some of the invert and do it safely. So we were able to accommodate that with the tunneling capabilities of tunnel liner plate and keep everyone safe while doing so.
So I have not gotten into tunnel liner plate. You and I have briefly talked about it, and it's something that we haven't actively promoted out here. Obviously, I'm going to get a lot more education on it. Is this a 75-year design life as well?
Yeah, and so one of the things you'll find with metal plate, or whether it be corrugated or plate or structural plate, tunnel liner plate, they make several different materials for tunnel liner plate, right? So galvanized, aluminized, aluminum, and every one of them has its own abrasion and corrosion and pH tolerance levels to it. And similar to designing like an HDPE pipe where you design for DR or ring stiffness coefficient, you have gauge as well, right? So gauge plays another factor into service life capabilities of a metal product. So when you want to add service life, you typically would beef up the gauge so that you end up with a thicker material, right? More material, longer life.
Yeah.
So aluminum and aluminized has terrific abrasion capability. So if you have a high bed load stream, a lot of rock skipping along the bottom, for 50, 75, 100 years, you can design a high abrasion capability product for that stream culvert.
Do you want me to go to the next slide?
Sure.
Oh, yeah.
So just
I
another
like
great
seeing
example. What's that?
I said I like seeing these kind of projects. Fun shapes, interesting. That's an interesting culvert.
Yeah, they are. And I mean, I think that's part of the affinity for these plate solutions is they fit a need in the sense that, a lot of these structures are so old and so far gone. I mean, they're beautiful structures, right? You just can't imagine how they put this stuff together 100+ years ago.
Yeah.
And both of these were incredibly gorgeous structures. From a kind of a bridge geek and a structural engineering geek, I really thought that they were really neat to look at. The two pictures on the left are right here in Maine, where I live, in Freeport. And the top picture on the left is the host. So this beautiful stone arch on top of wooden logs, believe it or not, underneath Route 1. So it's one of the heaviest travel roads in Maine. And we ended up putting a sort of like an underpass shape in there with some baffles for bed retention sills for eels. So, it met not only the structural component, but it also met the DEP, Department of Environmental Protection. It met their needs as well from a aquatic life sensitivity perspective. So, once again, salvaging this structure, not having to dig up 30 foot of roadway and Route 1, and able to pass all the needs of the structural and the DEP. And then similarly, kind of a similar shape, just a little bit wider on the top, as you can see, is this one we just finished 2 months ago, just north of Albany, is a 9'9" by 9 foot span. So 9'9" high by 9 foot span. This is, I think it was Clifton Park, technically, New York, and part of the old canal system. So really neat geography, and just understanding the whole canal system is a whole different ball of wax. But some of those headstones, the contractor, you can see in the bottom right there, they were actually able to salvage some of those headstones from the stream and put them back to where they originally were, and just build out that structure. So it's really a beautiful looking thing now.
So question,
Yeah.
when you're talking about, you were talking about eels, so here we do a lot of fish passages. Do you work with the manufacturer for the products to put those in prior to it shipping to the job site?
Yeah, so typically with, it varies, right? Project to project, material for material. In plated structures, they can be oftentimes bolted on in the field, right? So for like this here that you're seeing on the bottom left, that was a bolt-on connection. If it's a corrugated product that's coming off of a corrugated, or out of a corrugated plant, we would most often, at least here in the Northeast, we would weld those in. But I think they could probably accommodate you. And in a few slides, I think I actually show some HDPE baffles too, which we could do again in the plant, or we could do them in the field, depending on what works best for that particular project site.
Okay.
Great question, though. Okay, so this is one that is somewhat new to my portfolio, and one of the reasons I had an affinity towards it is, well, there's various number, but number one, they can do very large diameters, at this moment all the way up to 16-foot diameter. But you can see they can do some things that some of these other products and solutions we've talked about don't or can't do nearly as well, or necessarily the same shape. These eccentric reducers and things of that nature. This was actually born out of the sanitary market, but it fills a gap for me up here in the Northeast, because there's a lot of these unique shapes and sites that we're trying to push the hydraulic opening with these liners as far as possible. So there's no real nominal ID to these things, or OD. We can make pretty much any size and shape necessary and make them fully structural. And as you see here, full on AASHTO design. So it's all these things we talk about are standalone as far as structures. They don't rely on grout or the hose pipe. But you'll see, I think in the next slide, Cassie, if you want to go ahead and toggle over there.
Yep. On it. There we go. Oh, wow. Yeah.
So nice, egg shape for sewer, but we also make some really tight corner radius pipe arches for culverts as well, where we got some of these really cinched haunches. I've been dealing with a lot of these culverts. They were arches and they've crimped down a little bit over the last 40, 50 years, so the rise has gone like this underneath live and dead load. And so trying to fit in these maximum hydraulic openings within these little areas has been a unique challenge that the fiberglass GRP has been able to meet.
Oops. There we go.
And then, yeah, so this was the other gap, if you may, that I didn't really have. We can fit some other shapes in there, but what I found, you probably hear it, Cassie, out your way. We sometimes engineers and owners, they'll say, hey, I've got this 3-foot rise by 10-foot span box culvert that was built 100 years ago. Can we shove 3 round pipes side by side in here? And the answer is yeah, typically, but I usually caution and I say, oh, you're either going to restrict your hydraulics quite a bit, right? Because you've taken a rectangle and put 3 smaller pipes inside. And part 2 to that is they've possibly created a debris capture potential on the upstream end, because trees and twigs can get caught by reducing that area. Yep. So the GRP and its capability of doing boxes, I mean, you can see there on the bottom left, that was one that was done just north of New Hampshire, where they were able to do like a 4x4 box and just do it like stick pipe, like we do with some of these other solutions that we've been talking about. It goes in like But then
So
you got
is that bottom center one, is it a bell and spigot joint?
they're so the joints are like a low profile bell and spigot, so they don't add a lot of extra OD. So it goes together real slick and slim, so that you're not risking getting hung up on the hose pipe. So you can really push that hydraulic opening quite a bit.
So are you using a gasket? Are you doing some sort of seal wrap on the outside?
Typically for culverts, so this can be a gasketed joint. We can design that. I like this GRP solution because of its design flexibility. So it can be gasketed for some of these pressure, kind of low pressure applications.
Right.
But for stormwater, it's seldom do we ever need a gasket. We just put the joints together as a dry fit, and they're good to go for grout. So on the right, you got like that 3x10 example I was giving you. It's kind of hard to see, but you might be able to see on the top right, there's a tongue and groove connection. So the other thing about the box shapes and some of these other ones is we can panelize them. So, you're trying to go down through manholes sometimes, you're trying to, you've got really horrible, can't dig an excavation pit maybe, or you have to minimize that excavation pit. So the ability to go ahead and use some of these shapes and then panelize them and clamshell them. You can bring a plate in at a time, similar to the tunnel liner plate, you can bring a panel in at a time.
Mm-hmm. That's very cool.
Yeah. Now I realize this is all very 30,000 foot view type stuff, but I know Cassie and I were kind of talking for the folks on the call. I know Cassie and I were talking about maybe we do like a little mini series afterwards if someone wants a more specific Reline Live in the future. We could certainly talk more deep about some of these other solutions. But this is more on the unique shape offerings of GRP. So pretty much, I don't want to insert foot in mouth here, but if you've got a shape that you need, if we can think it up, we can probably make it. So you can just see some other unique shapes there. To answer the bottom left there, Cassie, that your question about the bell and spigot. So so you can see they're pulling that in with a winch system. Just basically, there's like maybe some 2x4s in the invert there. So they're just belling that up inside the hose pipe.
So they're sliding it in and they're snapping it inside the pipe?
Yeah.
Wow. So
it offers you some versatility if you need to come at the pipe from both ends, for example. If you had to, you could.
Okay. That's definitely been cleaned out too. You can see to slide that in there like that.
Oh yeah, absolutely.
Yeah.
And they've got some skid rails down at the bottom. Just basically, you can see kind of, yeah.
You guys have some of the coolest infrastructure though in the New England area compared to, I think, some of the stuff that we have out here just because it's so much newer.
Yeah. A lot of stuff to catch up on with not a lot of money.
Yeah. So this is a product I'm very familiar with.
It is indeed. Was it last week?
Yeah, hydrotite. Mm-hmm.
So this is a solution. A lot of, you probably find commonality here, Cassie. A lot of the RCP is typically, there's some that are out there that are really bad. It's abraded away, the steel's exposed, and it truly needs to be relined. But much of the RCP, the reinforced concrete pipe, is typically in okay shape with the exception of the joints. It's, with the frost, freeze thaw up here in New England, movement of the pipe either vertically and or laterally, longitudinally, we get these joint separations, and then sometimes you end up with soil migration or water like you see in the picture in the center, and then inherently you get a sinkhole on grade at your pavement surface, right? So these seals, they're a rubber seal with stainless steel hardware that go in very efficiently, and they're meant to basically stop the backfill from migrating through the joints. So it is truly it's not a structural repair, but it is truly something that can help add service life to a culvert just by mitigating the joint backfill loss.
Yep.
That's a solution, as you guys discussed, is available from 18-inch small to pretty much 18-foot large. So any diameter between 1.5 feet and 18 feet for the most part.
Yeah, they can customize them.
Yep.
Here's another view of those joint seals.
There you go.
What I thought was really interesting too, Don, is them being able to, so if your separation is greater than their extra wide, they can actually connect them together and make a larger fix, which I thought was really interesting. And I didn't know that until I sat down with Heather.
Yeah, I mean, in theory, you know, you could go the entire length of a culvert if you really wanted to.
Right.
Not a structural solution, but you know, I've got just like here on a pipe in Maine, we did one joint just to do like a demonstration, and that gap on that first joint might have been 7 to 8 inches or something. You could see the poor backfill that they used when they did this thing 60 years ago. When you look further upstream, and some of those joints are separated 18 to 24 to 30 inches even. Yeah. And you know, we'll usually put a stainless steel backer plate in behind there and try to add some service life to that joint and prevent further migration of those soils.
One thing that came up when we were talking about it was offset versus separation. So what's the largest offset you've seen this product work with?
Personally, a few inches. Bear in mind, I've only been associated with them for maybe a year and a half, but I think each joint definitely provides a unique, what's the word, challenge. That team is really, really good as long as you can go in and take measurements, which they will request, of the offsets plus the, you know, whatever the gap is.
Right.
Usually, as you said a second ago, they can customize some stuff, right? So they might not give you a nominal dimension band. They might make up one that, you know, can stretch a certain amount of offset plus horizontal gap. But a few inches is what I've seen to date. I'm sure there's going to be some where, you know, it gets even crazier, then we might have to figure something else out. But yeah.
Yeah, I'm curious. So, because we're new to that as well. So we're going to just start getting into the offsets and separations and how to recommend that.
Absolutely.
Okay, so what are we looking at here?
So you can skip right ahead. So this, I mean, I figure as part of the large diameter conversation, important to remember that, you know, and you guys do some plate and some other type solutions like that out your way too. You know, we have these what I call bridge span size culverts or small bridges, where there's an open waterway below. You have either native stream bed material or that invert is buried. You're on a footing. This is aluminum structural plate. Once again, a plate structure that has very high service life, great abrasion capabilities. And what you're seeing there is basically them plugging into one of the grout ports to grout the space between the liner and the host arch, if you may. So this one I think was a 15-foot tall by 30-foot span, roughly, plus or minus, that they were able to.
We actually, this is leads me right into kind of my closing out of Reline Live. This is actually the conversation we're having on Thursday. We're bringing on a bridge specialist from Contech Engineered Solutions, and he's actually going to be talking about these multi-plate structural bridge structures. So
absolutely, I mean, that's a lot. It's like you said a second ago, especially out here in New England. There's so many of these old stone arches that are historic. They're beautiful, right? Yeah. So most of the time you have this this desire to want to salvage the faces of the culvert and try to put the host stone, point the stone and put it back together the way it originally looked. Bearing in mind, there's a structure there that you have to salvage and you're trying to keep people safe. How do you do that? You can fix the bottom, the structural component, and try to key in some old stone or do like you said and put in like a fascia stone or something like that.
Right. Yeah, so that we'll have a full half an hour on that on Thursday. So that'll be a good topic, because there's a lot of these we're seeing a lot just in Idaho, and then now even beyond, you know, either replacing or lining
Sure,
bridge structures.
sure.
Let's see. Ooh, that turned out great.
Yeah, so kind of you can see them sliding it in on the new footing. Minimal disturbance, they're not disturbing the front faces at all, and they basically, you know, fix the structural component to back to full capacity.
Perfect.
Here we go. Timely. So you had asked the question when we were talking about the main culvert there with the stone. Yeah. So oftentimes, and especially more now than ever, aquatic sensitivity is a high consideration for DEP, DES, whoever it may be. So it's kind of a double-edged sword. You're trying to maximize flow, right? So you're trying to get the best smooth or best waterway area, whatever it may be, that's going to optimize that inlet or outlet control culvert, but also maximize the ability for a native stream bed material. And so what you're seeing here is a high density. So you've got a corrugated metal in the top left with a welded. You had asked that question too about welding baffles, just like a V-gear in there. And you can see the grout ports sort of in the wall, so they can hook in to grout those in place. And then HDPE baffle in the bottom left inside actually of a interior open profile pipe. So it's a corrugated. If you're familiar with like the ADS or the Lane corrugated outside pipe, imagine that on itself.
Okay.
It's got like a smoothish outside skin, and then you've got a corrugated interior, so a native silt material can fill in those things and help create a natural stream bed environment for aquatic life. So that, the right-hand side on that previous slide there, that's actually a Connecticut DOT job. That was like 600 feet of 54-inch, I think, that we put in for them. Twin barrel.
Alabama.
Yes. So this is what they call in the industry steel reinforced high-density polyethylene. This is a solution that I've used quite a bit in the culvert rehab space for municipal and some DOT, but quite a bit of municipal applications where you're trying to, as you can see, the wall is fairly thin, but fully ASHTO because of the 80 KSI steel inside, and you have the abrasion resistance of the high density polyethylene. So it's super lightweight, and when you have these long runs of culvert, it certainly can help to push and or pull the material in place and do a nice job. Now, Alabama's a little far from me being a Maine fellow, but I'm familiar with the job, and I brought it up just to show you the magnitude of what it's capable of doing. But we actually just finished one for a railroad company in New Jersey where they actually self-performed the install, and then they subcontracted the grout, and they did a fantastic job. It was an 8-inch. Here's a good example. So this is steel reinforced polyethylene, same product you saw in the previous slide here. This was, believe it or not, old tunnel liner plate and some multi-plate on the upstream end, and I literally could fall inside that hole there and probably go up to my chest in it. The hole was that big. This is underneath. Yeah. So Massachusetts DOT, I-91, both north and southbound, and also railroad tracks. And you can see in that bottom left picture just the amount of backfill that was kind of seeping through the holes in the pipe. So that was 66-inch steel reinforced HDPE. And I like the photo on the left. I was able to catch that as the train was going over it. And they were sliding the last few sticks of pipe in and button that thing up, put a brand new head wall on it, and get out of there. Another one that's a little bit outside of my geography, but it would make my one of my colleagues proud. This was, I want to say, 7,000 feet of of steel reinforced polyethylene. And if you click to the next photo there, you'll be able to see they had 7 runs. So each one I think was about 1,000 feet. I could be plus or minus a few hundred, but right there they had, obviously they were segmentalizing how they were going to do each barrel and then grout that thing. So it took a lot of grout too, but they were able to do, you can see how many rail in that previous photo, you saw how big that rail bed was or yard was. So they were able to fix that.
This is just another shot of that pipe, correct?
Yeah.
Oh, my screen just flashed.
All right.
There we go. So do we have any more questions from the audience for Don? I'll give it a couple of seconds here to see if anybody has anything else that we want to address before we sign off. Keep in mind, you can register for the next one where we will talk a whole 30 minutes about those multi-plate steel bridges that he brought up. You can go to tdpipesolutions.com, Reline Live, and register there. I don't see any more questions coming in. So thank you, Don. This has been great. I just learned about a bunch of products that we haven't really dived into yet with TD Pipe Solutions, but obviously I now know what I need to look at.
Absolutely. You know, it was a pleasure. Thanks for inviting me on short notice. And
Yeah.
if we can follow this up and do some more along those lines at deeper level, let me know anytime. I'd be glad to join you.
Yeah, let us know, you guys. When you get you'll get a thank you email for joining us tomorrow. You can respond to that and it comes directly to me with ideas on other topics that you think would be great for Dawn to come back on. If you want a specific product, we can spend 30 minutes just on that product itself. So let us know. We're having fun doing these.
Absolutely.
All right, thanks, Dawn. Bye, you guys.
Thanks, Cassie. Appreciate it.
Yep, same.